Hello everyone. Today in this video we'll see how to find the solution of homogeneous differential equation with some conditions. With some conditions will be given, so we have to find the solution. For such solution we call it particular solution. So let us find particular solution of homogeneous differential equation. So what is particular solution? Particular solution is a one when some conditions are known. So let us solve this particular differential equation. So this is a homogeneous differential equation. Homogeneous differential equation because the value of this equation is 0 here. So this is, or phi of x is equal to 0 from the standard equation format. So this is a given problem. So let us solve this, or let us find out the particular solution of this particular linear homogeneous differential equation. So now the given differential equation I can write it in the form of differential operator. So let me write this. So this is a d square y plus 4 dy plus 4y is equal to 0. Now let me simplify this. So we have d square plus 4d plus 4 into y is equal to 0. Now the auxiliary equation is m square plus 4d plus m square plus 4m plus 4 is equal to 0. Let us find the roots of this, since we have this is a can be solved with the direct factorization method. So we have 4 as a product and we have 4 as a sum. So 2 into 2 gives us 4 product, and if I add 2 plus 2 it gives me 4. So I can factorize this. So m square plus 2m plus 2m plus 4 is equal to 0. M into m plus 2 common here, so it is m plus 2 is equal to 0. So the roots are m is equal to minus 2 and minus 2. So there are two roots which are repeated. So the solution or the complementary function y can be written as c1 plus c2x e to the power minus 2x. Since the root is minus 2 and it is repeated, we use this format for the solution. So this is complementary function or the solution of the equation. Now there are some conditions given. So let us find the particular solution of this. So first thing is, it is given that y is equal to 0 and y dash is equal to minus 1. Y dash is nothing but dy by dx. So this is nothing but dy by dx, or it is d is minus 1 dy at x is equal to 1. So let us use the first condition, that y is equal to 0 at x is equal to 1. So y will be equal to 0 at x is equal to 1. So let me put 1 in the place of x. So it is e to the power minus 2. So we have, this gives us 0 is equal to c1 plus c2 into e to the power minus 2. This e to the power minus 2 I can shift it to other side, so that becomes 0. So c1 plus c2 is equal to 0, or from this implies that c1 is equal to minus c2. So we got c1 is equal to minus 2. Let us make use of the second condition, that is y dash is equal to minus 1 at x is equal to 1. So what is y dash? Y dash is dy by dx. So from the first equation, there is this equation. Let me take this as equation 1. So from equation 1, if I differentiate that, I will be getting dy by dx, that is y dash is equal to, let us differentiate this. Now since this is having two terms, one is this and the second one is this in terms of the independent variable, so we have to go for UV rule. So let me use the product rule, UV rule for this. So let me take this as a first term, this as a second term. So the differentiation will be first term into differentiation of second term. So what is differentiation of e to the power minus 2x? So it is e to the power minus 2x into minus 2 plus, now the second term, that is e to the power minus 2x into differentiation of the first term. So differentiation of the first term is differentiation of c1, since it is constant, it is 0, plus c2x differentiation is c2. So we can write y dash is equal to minus 2 c1 plus c2x e to the power minus 2x plus c2 e to the power minus 2x. Now let us use a condition at x is equal to 1, y dash will be equal to minus 1. So I will substitute that here. So y dash will be equal to minus 1 at x is equal to 1. So wherever x is there, you just put 1. So e to the power minus 2 plus c2 e to the power minus 2. Let me simplify this further. So here c1 plus c2 value already known, it is 0. So substitute that. So it is minus 1 is equal to 0 into this becomes 0. So we have c2 e to the power minus 2. So we have a c2 will be equal to c2, from this c2 will be equal to minus 1 divided by e to the power minus 2. So let me simplify this further. I'll shift this term to the numerator. So I'll be having minus e to the power, this becomes plus 2. So 2. So c2 is minus e to the power 2. So what is c1? So from first solution here, we got c1 is equal to minus c2. So I can write c1 is equal to minus c2, which is equal to minus, what is c2? c2 we found out, it is minus e to the power 2. So it is minus e to the power 2. So this becomes e to the power 2. E to the power 2. Now the solution y is equal to, we have already written the solution here. So let us substitute c1 and c2. So what is c1? c1 is, let me write this once again, c1 plus c2x e to the power minus 2x. So c1 is e to the power 2 plus c2 is what? c2 is minus e to the power 2. c2 is minus e to the power 2. So minus e to the power 2 into x whole into e to the power minus 2x. So here e to the power 2 is e to the power 2 is common out. Let me write this outside. So e to the power 2 into 1 minus x into e to the power minus 2x. So this is the solution. What we have done here is, first we have found out the solution of the given linear homogeneous differential equation in terms of arbitrary constants. Since the conditions are given, some conditions are given, so we can find out the values of these arbitrary constants c1 and c2. That is what we have done. Using the conditions, we have found out the arbitrary constants. Then we have written in the solution equation. So this becomes the particular solution of the differential equation. Particular solution of the differential equation. Let me take one more example. So solve d square y by dx square plus 4 dy by dx plus 5y is equal to 0. And the conditions are given here, given that y is equal to 2 and dy by dx is equal to d square y by dx square when x is equal to 0. So let us start. Now d square y by dx square plus 4 dy by dx plus 5y is equal to 0. Let me write this homogeneous differential equation in using differential operator. So I can write d square y plus 4 dy plus 5y is equal to 0. Now let me simplify this. So it is d square plus 4d plus 5 into y is equal to 0. Now the auxiliary equation becomes, auxiliary equation is m square plus 4d plus 5 is equal to 0, not d, sorry, 4m. 4m plus 5 is equal to 0. Now let us find the roots of this. To find the roots of this, direct factorization is not possible, since the product here is 5 and the sum is 4. So let us go for that standard equation, algebra equation method. So I can write minus b plus or minus square root of b square minus 4ac divided by 2a, that will be the root. So here m will be equal to, root will be equal to minus b. From this equation, minus b, that is the second coefficient of m. So minus 4 plus or minus square root of b square, that is 4 square, minus 4 a is coefficient of m square, that is 1, c, that is 5, divided by 2 into a is coefficient of m square, that is 1. So m will be equal to, simplify this, so you will get minus 4 plus or minus square root of 4 square is 16, 16 minus 20 is minus 4 divided by 2. So let me write this. So minus 4 by 2 is minus 2 plus or minus root minus 4 by 2. So this can be written as minus 2 plus or minus square root minus 4 is 2 root minus 1. Root minus 1 I can write it as I divided by 2. So this becomes minus 2 plus or minus I. So m, that is the roots of the auxiliary equation, is minus 2 plus or minus I. So if you see here, this is pair of roots are pair of complex roots. So we'll write the solution for this. So solution y is equal to e to the power, so this, that is minus 2x into c1 cos this coefficient, that is 1 there, so cos x plus c2 sin x. So this is the solution what we got, that is nothing but complementary function. Now with the given conditions, let us find the particular solution. So what are the conditions given? So one is y is equal to 2, and the second one is dy by dx is equal to d square y by dx square at x is equal to 0. So let me use this first one, that is y is equal to 2 at x is equal to 0. So let me take this as equation 1. So from equation 1, let me substitute the value of y as 2. So 2 is equal to, and value of x as 0. So e to the power 0, that is 1 into c1 cos 0 plus c2 sin 0. Sin 0 is 0, cos 0 is 1. So we have from this 2 is equal to c1 into 1, that's it. So c1 will be equal to 2. We got c1, now we have to get c2. So let us use the second condition. So the second condition here is dy by dx is equal to d square y by dx square at x is equal to 0. So at x is equal to 0, this condition satisfies. So we have to first find out dy by dx and also d square y by dx square. So use the first equation. So from equation 1, differentiating that, so it is dy by dx is equal to, again we have two terms, so go for product rule. So it is e to the power minus 2x into differentiation of this. So it is c1 minus sin x plus c2, differentiation of sin x is cos x, plus second term into differentiation of first term. So second term is c1 cos x plus c2 sin x, differentiation of first term, that is e to the power minus 2x into minus 2. So, if you see here now, this term, this is nothing but y, that is c1 cos x plus c2 sin x into e to the power minus 2x is nothing but y. So, let me replace that with y. So, dy by dx is equal to e to the power minus 2x minus c1 sin x plus c2 cos x. This is y. So, I will write minus 2y. Done. Why I have replaced this with y? Because again I need d square y by dx square. So, we have to differentiate once again. If I retain this term as it is, we will be getting more terms. So, just to simplify that, let me write this as y. Now, we will substitute x is equal to 0 here. So, what will be getting? So, dy by dx value we do not know. So, let us write as it is. So, x is equal to 0. So, x is equal to 0, if I put here e to the power 0 is 1. So, it is minus c1 sin 0 plus c2 cos 0 minus 2y. So, what is y value? Y value at x is equal to 0 is 2. We have already found out. So, this becomes minus c1 plus this becomes this is 0. This is 0, sin 0 is 0, cos 0 is 1. So, c2 minus 2 into y value is 2 at x is equal to 2. So, this is dy by dx. So, we got c2 minus 4 as dy by dx. So, we got dy by dx is equal to c2 minus 4. So, now we also need d square y by dx square. So, let me use this equation, this, write this as to equation 2. So, from equation 2, let me write, when I differentiate this, this becomes d square y by dx square is equal to, again we have to use product rule over here. So, let me write first term as it is. I will do the differentiation of second term, that is this. So, it is a minus c1 sin x differentiation is cos x plus c2 cos x differentiation is minus sin x. Product rule for this. So, plus this term, second term, that is minus c1 sin x plus c2 cos x into differentiation of first term, that is e to the power minus 2x into minus 2. Do not stop here, we have one more term over here. So, differentiation of that. So, minus 2 y dash. Y dash is nothing but dy by dx, the value of which is already known. So, we will substitute all these, and also d square y by dx square is equal to dy by dx at x is equal to 0. So, let us find out d square y by dx square at x is equal to 0. So, at x is equal to 0. So, let me write the equation at x is equal to 0. This equation becomes, so d square y by dx square is equal to, at x is equal to 0, this is 1. So, it is a minus c1 cos 0 is 1 plus c2 sin 0 is 0. So, I will not write that term, and this becomes plus this term now, this term. So, it is a minus c1 sin 0 is 0 plus c2 cos 0. So, it is c2 e to the power 0 is 1 into minus 2. Minus 2. Y dash is what y dash is? We already have, it is c2 minus 4. C2 minus 4. So I can again substitute d square y by dx square is equal to C1 we already got, that is 2. So it is minus 2 plus, or sorry, minus 2C2 minus 2C2 plus 8. So we have d square y by dx square is equal to 6 minus 4C2. So now let us compare dy by dx is equal to d square y by dx square. How? This is given in the question itself. The condition dy by dx is equal to d square y by dx square at x is equal to 0. At x is equal to 0 condition we have already applied. So, we will just compare it. So, what is dy by dx we got? It is C2 minus 4 is equal to d square. So, it is 6 minus 4C2. So, we will simplify this. So, we have a 5C2 is equal to 10. So, what is C2? C2 is equal to 2. So, we got C1 is equal to 2 and also C2 is equal to 6. So, C1 is equal to 2, C2 is equal to 2. Solution we got. Now, let us write the final particular solution. So, from here we have already written the particular solution, equation 1. Not particular solution, complementary function. So, we will write the particular solution. So, y is equal to e to the power minus 2x c1 cos x plus c2 sin x. This was the solution we had written in terms of arbitrary constants. So, now let us substitute the arbitrary constants here. So, e to the power minus 2x, c1 is 2, so 2 cos x plus c2 is also 2, so it is 2 sin x. So, this is a particular solution. So, this is about linear solution of linear differential equation when some conditions are given. So, next let us see how to find out the solution of non-homogeneous equation, that is in the next video. Thank you.